All right, so on the 84 calculator, here's where we find our finance thing. So if you're 84 people, you're following along. There's a button that says apps. Under apps, there is something that says finance. Hit enter. Most of what we are going to use is called the TVM solver, number 1. Okay? So if you hit enter where it says TVM solver, you're going to hang out here. And if you refer to the sheet that I gave you, underneath your pictures, which show you how to get here if you forget, there's a bunch of bullets that say what each of these things represent. We're all going to talk about that as soon as we're both in the same place. Okay? Inspire people. Okay? If you are in your normal calculator part, okay, you are going to go to menu. There is a finance part of your menu, and you are going to use the finance solver. That is the same thing as their TVM. Okay? So we should all have a screen up that looks either like this for the Inspires or very similar this for the 84s. Are we all there? Okay. Now, real briefly, I just want to talk through what each of these things mean. Okay? N is going to have to do with the time. It is also going to have to do with the compounding periods. So underneath the bullet point for N, it says N is the total number of payments. Or you can also write next to that, total number of compounding periods. Okay? So a good example of this would be if it says, this is happening for 3 years, compounded monthly. To get your N, you're going to say 3 years times 12 months. Okay? Note that you don't have to do that math in your head. Your calculator can do it for you. So like if I know it's 3 years at 12 months, I can say 3 times 12, and my calculator will do that for me. Okay? So you can enter in 3 years at compounded monthly. I is the interest rate. Okay? This is the one and only time in a math class that you are not going to write your interest rate as a decimal. It is entered exactly as it is. If it's 5%, you enter 5. If it's 3%, you enter 3. You do not switch it out to a decimal. The program is going to do that for you. Okay? PV is called present value. Okay? This will be kind of a new term to you, but you're going to see a lot of present and future value terms. Okay? So PV is present value. A little bit further down, you see FV, future value. Okay? Present value, future value. Payment is the payment amount. We're not going to touch that until later. Okay? That will be like the second lesson or more. And then if you're in 84, you see this P/Y or C/Y. These are often going to be the same thing. Okay, you see this at the bottom. It's either payment periods per year or compounding periods per year. It depends on whether you're investing money or paying into something. But this is basically your compound amount. If it says monthly, that's going to be a 12. If it says daily, that's going to be 365. Annually, it's 1. Okay? If you don't know what something is, you are either on the 84 going to put in a 0 for it, or on the Inspire, you're going to leave it blank. And that's what it's going to solve for you. Okay? So that's what our variables are all in. So we're just going to practice using this now, using example number 1. Okay? So now we are all going to look at example number 1. I'm going to lose the calculator thing, and you're going to learn how to use your calculators as we go, because I'm not going back and forth between 2 calculators and notes. We've looked at that. We're going to stick with that. If you need help, that will be when I walk around for you. Okay? All right, so on the first one, I will show you. After that, I won't. Okay? If I look through question number 1 here, it says $500 amounted to $588.38 in a savings account after 3 years. Interest was compounded semi-annually. What does that mean? Twice a year. Find the nominal rate of interest. That's a very fancy way for, say, find the interest rate. Okay, compounded semi-annually, that was earned by the money. Okay, I have to go through this and figure out what goes where. Okay, so first thing I look at is N. N is the number of compounding periods, which means it accounts for time along with compounding. So what's my time? 3 years times how many times a year? 2. So you can enter 3 times 2, or we're all capable of saying that's 6. Yes? Okay, so n is 6. We would like to find the interest rate. So on the Inspire, you're going to delete anything out of the interest rate slot. If you're on the 84, you're going to put that in as a 0. Okay? That's what we're finding. That's our question mark. What's next? Present value, right? Present value is what you start by investing. So in this question, what is the present value? 500. Now, here's the one weird thing about this programming. Okay? This is what is called a cash flow model. So it follows payment in and payment out. So technically, I'm paying $500 into this. Okay? So when you enter your present value, you are going to enter it as negative 500. Not because you're investing a negative amount, but because you are paying $500 into this. Okay? Payment amount, we're often going to leave this blank in these kind of problems. When we talk about payment amount, the PMT, we're going to talk about that as like if you pay a certain amount each month over 3 years. We're not doing that. We're sticking something in one time. So that's our current value, present value. So we're going to leave our payment as 0. Future value. What is my future value? 588.38. That you're going to leave as a positive number because cash flow, this is what you're getting back out. This is payment to you. Okay? And then PY and CY, you can enter them both. Often if you enter one, the other one will change automatically. This is your compounding times per year, which is what for this? 2. All right. So, real quick, going back to one of my calculators here. I'm going to go into this and say, okay, my N, we said is 6. Interest rate is what we're finding. Present value is negative 500. Make sure to use the negative sign instead of the minus. I'm leaving payment as 0. Future value was 588. Oops, it did not stay there. Okay. Hang on, here we go. Future value, 588.38. Now, when you are ready to solve, if you are on the 84 calculator, you are going to scroll to what you are solving for, and you are going to hit alpha and then enter. So what am I solving for in this problem? Interest rate. Okay? So for my 84 people, I'm going back up to I, using my up arrow, and I'm going to hit alpha enter. For the Inspire people, you should have left interest rate blank. And so you should just be able to use your cursor. Hang on. I just did something wrong already. I told you this was going to happen. What did I do wrong already? Did anyone else get an error? Nope, there we go. All right, mine turned out. All right, so when I hit alpha enter, it gives me my interest rate back out. If I was doing this on my Inspire calculator, you're going to just go use your arrows to go back. Sorry, trying to switch between the calculators. Like I said, this will be the one time I show both. So on my Inspire calculator, I put in 6 here. Wow, I can really not see this. Interest rate, I'm going to leave as either 0 or just delete it out and keep doing the rest of the things in here. Okay, I'm going back to my computer to type this in because this is painful. Trying to control it from my iPad. All right. So that, I would like my present value. Is this frozen? Okay, delete. Okay. present future value and that is going to be 2. All right, so the Inspire, once you are ready to solve, you just use your arrow keys or your tab keys to get back up to the top with I. So my cursor is now in the I will just hit enter, okay? We would round this to about 5.5%, okay? All right, so example 2 is a common question for stuff that we do with this. We want to know at what rate of interest compounded yearly will money double in 8 years, triple in 8 years, and have a 60% growth in 8 years. Okay, so if I want to set these up, number 1, does it tell me how much I'm investing to begin with? No. Make up an amount. How much do you want to invest? $100. Sounds perfect. So my basic setup for this is going to be my present value is going to be 100. Therefore, what is my future value going to be? 200. This is part A. What's going to change in part B? Present value will be what? My present value stays 100. My future value becomes what? 300. Right? Triple. Okay, what about a 60% growth? That means, okay, $100 becomes how much with 160? That's a 60% growth, adding 60% back on top of it. Now, I set that up for those 3. What else do we enter for all 3? What are we finding?
Yearly.
Compounded yearly means which thing? What's yearly telling us? The PY and CY are both going to be 1, or PPY, CPY, whichever one you're looking at, okay? That also helps me find N, okay? For each of these, N is the times it's compounded in the amount of time. How much time is this for all of these? 8. Compounded yearly means that really my N is just going to be what? 8, because it's 8 once a year for 8 years, right? So you don't have to multiply by the compounding times this time because it's once a year. 8 years times once a year is still 8. What are we finding for all 3 of these? The interest rate. Still, payment doesn't matter. I will tell you when payment matters. That's not going to be this class, okay? So take a minute at your own tables and see if you can solve for your interest rate on all 3 of these. Should your interest rate be the same for all of these? Absolutely not. All right, so my interest rate for, oh, did my internet go out? All right, so what did we say? The interest rate for A was 9.1. Interest rate for B was 14.7. Was that right?
Yes.
Okay, and your interest rate for C was 6.1. Any issues getting our answers back out? Keeping in mind that we enter our present value as a negative 100, because that, if you get the no sign change answer, that's what's happened. You've not put a negative in for your present value. Okay? Let's read example 2 and see what we see. Okay? Or 3, excuse me. All right. This time I want you to set up what goes in here. How long will it take for $600 to amount to $900 at a rate of 6% compounded quarterly? This time, what do we want to know? N. Now, N is not going to be our final answer, but I want you to start by plugging in stuff and solving for N, and then we'll come back to that. This gives me the number of compounding periods. What is the issue with that? How have we been entering N in so far? N is the time times the number of times it's compounded per year, right? When we plugged in N in example 1 and 2, we got N by saying time times the number of times compounded per year, right? Which part of that do we know right now? Do we know the time or do we know the number of times compounded per year? Right. In this problem, how many times is it compounded per year? 4. Okay. So how am I going to take our n value and solve for time? Divide by 4, right? Because I would have originally gotten that n by taking time and multiplying it by 4. So my final answer is not going to be this 27.2. I'm going to take 27.2 and divide by 4. So I'm going to get about 6.8 years when I divide. So you just have to be careful that you don't think n is immediately your time. There's a little bit we have to do on our own. Okay? All right, so then we have this thing called effective rate and nominal rate. Okay? This is, again, one of these things that, doesn't make a whole lot of sense to me. Okay? This is my best way to explain this. Nominal interest rate is what you are given. Okay? You're given it's 4% compounded quarterly. You're given it's 6% compounded annually. The nominal interest rate, as soon as you throw a compounding into it, compounded quarterly, compounded daily, compounded monthly, that messes with your interest rate. It basically changes it. The more it's compounded, the higher the interest rate actually comes out to be. And so that's what this effective rate thing is. Okay, so if let's say I have 4% compounded annually, that's not going to change my interest rate because compounded annually is just once. It just keeps it the same. But if I say 4% compounded quarterly, you're going to get more than the person who compounds annually, right? If you compound daily, you're going to get even more. So the effective rate is a second interest rate that takes into the account the amount of times you're compounded. There's this lovely formula for it. Good news, your calculator also does this. Okay, this is the one thing that is not in the solver. This is at the bottom of the page for each one of you guys. Okay, it says nominal and effective interest rate there. Okay, so I'm going to pull my calculator up again, and I'm going to show you where to find this. This is also under the finance menu. It's just not in the same solver. So if you want to take a nominal interest rate and change it to an effective one or vice versa, for the Inspire people, you're going to go to menu. And you're going to use finance again. Okay, so your finance menu. I have no idea why that's not clicking there. Let me escape this. There we go. Okay, let's see if this works. Nope. All right, I cannot use this. All right, hang on for Inspire. I got to quit this and come back to it. Not working. Perfect. All right, my 84s under apps, finance. Instead of choosing TVM solver, scroll down. You see this B and C, nominal and effective. Okay?
Still in finance?
You're still under finance. Just scroll down to B and C. You can, if you want to change it and get an effective rate, you're going to choose effective. If you want to change an effective into a nominal, you're going to choose nominal. So for this one, you're going to choose C. Okay? Oops. After I quit this other thing, I don't want it to drop into this. Let's clear. Clear. Quit. And then I'm going to go do that, okay? Under apps, finance, go down, find effective. You want this to go into your regular calculator part, so it's going to drop here. I'm going to tell you what to put in it in a second, okay? Inspire people. Under finance. Okay? Yours is under interest conversion. You can either do nominal or effective. Okay? You're also going to choose effective. So, if I go back to my notes here, in example 4, it says what effective rate is equivalent to a nominal rate of 6% compounded semi-annually. So for both of you, when you type stuff in, you're going to use the effective command because you're trying to change it into an effective rate. You are going to first type the number of times compounded per year. So this semi-annually would be what? 2. And then you are going to do the interest rate. Is that the right order? Someone look at the paper for me. What did I say on the paper? Interest rate, then number of times compounded per year. Sorry, back up. Interest rate is 6, compounded twice a year. What would it look different for B, compounded quarterly? Okay, it's a comma. Yep. So it would be 6, 4. Okay. So take a minute and use those commands to type that in. The comma on the 84 is right above the number 7. The comma on the Inspire is down in that left corner or something like that. Okay.
Is that formula like if you were to do it by hand?
Yeah. It's lovely, isn't it? So if I do 6, 2, I get 6.09. In other words, a 6% compounded semi-annually is the same as a 6.09 compounded annually. So then a 6% compounded 4 times a year should be even higher. The more you compound it, the higher the effective rate is going to be. So a 6% compounded quarterly gives me about 6.14. So in other words, a 6% compounded quarterly gives me about a 6.14 compounded annually. Same thing. Okay, so the more you are compounded, the higher that's going to get. We're back to the finance thing. Okay, so go back to your finance menu on this one. If they don't tell you how much to invest, make up an amount. 100 sounds great. Okay, so if I go through this, and it doesn't say how many years either, does it? Okay, so let's go with 1 year. Okay, so if it doesn't say, we're just going to go with 1 year. So in example 1, we're going to do 6% compounded daily. Let's set that up. If it's 6% compounded daily for 1 year, what's my N going to be? 365. What's my I going to be?
6.
Okay, what is my present value that we're making up? 100. So I'm going to type it as negative 100. We're going to ignore payment. Okay, we don't know future value in this one. Because what are we trying to find? Which one is better? Therefore, we're asking which one has a higher future value. What's PY and CY for this one? Compounded daily. 365. The second option is 6 1/8% compounded quarterly for 1 year. So what's going to change here? What's going to be my N?
4.
4. I is 6 1/8. Can you enter that as a fraction? Probably not. I would have to do 1/8 in my calculator. That's going to be 6.125. Use that. I'm going to keep my present value the same. And my PY/CY is going to be what for this one? 4. How do we tell which one's the better investment? What value are we going to find for both? The future value for both, and see which one is higher. Okay? Take a minute and do that. All right, it says an investment is compounded monthly. Find the nominal rate that is equivalent to the effective rate of 8%. This time we're given the effective rate. Remember we did that translation between a nominal and an effective? You can do the reverse of that. That's just using the nominal command. So see if you can find that in your finance part. This time we're going to choose the nominal one. And remember when we did that, what went first in the parentheses? This time we're switching an effective to a nominal. So this time we choose nominal. Nom. Yep. Which is B. What goes first in the parentheses?
8.
The percent. So that is your 8. You go to finance and go to interest conversions for you guys. Again, if you don't remember how to get to these things on the Inspire, look, I like screenshotted the exact thing that you go to here. This is how you find this. On the 84, I did applications, finance, and then scrolled down to where it is. I have like your screenshots on your papers. Hang on to this. Okay? So first thing that goes in is your 8%. Second thing that goes in is what? 12. Why 12? Compounded monthly. Okay? So if I type that in my calculator with a comma in between, I get 7.72%. Remember, the effective rate is typically higher than the nominal because of the more compounding. So this is going backwards now. That's okay. Okay? This would be, if you're given a 7.72 interest rate compounded monthly, you get about 8% in reality. Okay? All right. Now, 8 will be the last one we do in this section, but we are going to take a quick look at just a few formulas with present value. It's just different solving. So I'll show you that quickly. Okay? I told you guys this is a little bit tedious, but think about doing this all by hand. Just, it would be a lot slower. Okay? All right. When I read example 8 here, we have two investment opportunities. We have $10,000 at 11% compounded monthly or $9,700 at 11.25 compounded quarterly. The first kind of like, what's wrong with this problem comes with the question. Which has the better effective rate of interest? Did we ever get an effective rate out of our solver? No. What kind of interest rate do we get out of our solver? The normal one, right? So if I want the effective rate, that means I'm going to have like a part 2 to my problem. Okay? So let's just handle this one thing at a time. Do you guys feel comfortable in finding the normal interest rate for both? Or not interest rate, excuse me. Oh. Okay, 2 parts. Effective rate. How do you find effective rate? Given a nominal rate. EFF. I just have to do that twice, right? So take a minute on your calculator, find the effective rate for investment 1. Okay, and investment 2. Then we'll answer question 2. All right, so investment number 1 had the better investment. Investment number 2 had the higher effective rate. All right, now, I'm going to go very, very quickly in the second part, okay? All that is changing in this is what you are solving for. Previously, this was a different lesson because you were solving using a different formula. Here, this is just solving for present value rather than future value, which means you're solving for a different variable in your solver, okay? So when it's worded this way, in number 1 here, find the present value. That immediately means that I am finding PV. That's my question mark. It says $1,000 due. That's your future value. So at the end of this time, you have a future value of $1,000. Interest rate's 9%, compounded monthly. Okay, so what's my N going to be for this one? 12 times 3. My PV and C, or PY and CY are going to be 12. And my I is going to be 9. So this time, rather than solving for the future value, we're solving for the present value. So if you go into your solver, my N is going to be 3 times 12. My I is going to be 9. I'm going to leave PV blank, or on the 84 put in a 0. Future value is 1,000. I put that in as a positive number because it's future value. PY and CY are both 12. I go back to present value and solve for that. What kind of number am I going to expect to get out of my present value? A negative, but I'm not going to write it down as a negative. Okay, because remember, you're given present value and investment as a positive number. You just, according to our program, type it in as a negative because you're putting that money in. Okay. So when I solve for my present value on this one, my calculator tells me PV equals negative 764.15. Okay? But I'm going to write down the positive number as my answer, because that is what I'm investing in at the beginning. Does it make sense that that would be smaller than the future value?
Yeah.
Yes, because you're investing 764 and getting 1,000 at the end. Okay? All right. So using that same concept, go ahead and set up 2. All right, so once we check our present value on this one, we're skipping example 3 because example 3 is absolutely horrendous. There's no way to do it by hand, and I've never seen it come up on a quiz or a test, so I'm skipping it. On example 4, you have the opportunity to have 2 different investments. You can invest $5,000 in a business such that at the end of the 5 years, you have $6,300. Please understand in this that that is not asking you to do any math. They are telling you investment 1, you put in 5,000, you get out 6,300. Okay? That's investment 1. There are the facts. Investment 2, you are being asked to do math. Okay, so investment 2, you are putting in $5,000 in an account that pays 6% compounded semi-annually. You would like to know which is better. Okay? Of course, this must be after the same amount of years. So how many years? 5. What are you finding in your solver for this one? Present value or future value? Future. Okay, so set that up. N is going to be 5 years compounded semi-annually. Interest rate is 6%. Present value, you're investing $5,000. You are finding the future value on this one. And PY and CY are 2. So let's see what our future value is on that one. All right, so your future value on the second one, I get $6,719.58. Yes? Good? All right, last thing I'm going to show you how to do is called net present value. There's a lovely formula for that. We do not want to do that by hand. Okay? Net present value, I did not get on your sheet there, but I will for like our second copy of it that I'll give you next class. So net present value is found under the finance part. So on the 84, if you go under the finance part and scroll down, there is something that says NPV. Okay? On the Inspire, if you go under menu, finance, and you go to, I think it's under cash flows. Yes, you have net present value. Okay? You want to clear out whatever you had in that solver because you don't want it to go into there. You want to choose net present value and have it drop into your calculator part. Okay? So what I mean by that is you want on your regular calculator part to have just this right now. Okay? Now, you have to know for this the commands that go in there. Okay? Which I swear I wrote down for myself somewhere, and I don't remember where I wrote it down. So just hang on. This is one of those, like, it just literally says NPV and opens the parentheses. So, like, if you don't know what to type in, you can't use it. Right? So, what you type in after net present value, the first thing is the interest rate. So if I read through this problem, what's my interest rate? 7. Okay? So that's going to be my interest rate. Cash flow at time 0 is what you put into the account to begin with. Okay? So what is that in this problem? 20,000. Okay? So I'm going to lead with my NPV being my interest rate of 7%. Comma, think cash flow. When we invest in something, how do we enter it? negative. You're putting in 20,000 to begin with, comma. Then you have to find these squiggly brackets. Okay? The squiggly brackets for the Inspire are second and, where are they? Second and right above the parentheses. The right parentheses. For the 84, it's second and right above each of the parentheses to open and close them. Within those parentheses, you are putting in the cash flows that you get back out. Now, here is the trick to this. Okay? Look at the table you are given. They only gave you what cash flows you're getting back out in what years? 2, 3, and 5. Okay? You need to fill in what you got out in year 1 and 4. If they don't list it, what is it? 0. So here's what mine's going to look like here. You get out 0 in year 1. You get out 10,000 in year 2. You get out 8,000 in year 3. I get out 0 in year 4. And I get out 6,000 in year 5. I close my squiggly brackets and I close my parentheses. Okay? So I had to fill in the zeros for year 1 and year 4 because there was nothing that came out then. Okay? All right. So let's see what we get back out of this in our calculator.
That's actually kind of
Net
weird.
present value is a negative number, therefore it is not a worthwhile investment.
That's like saying